30 minutes outside Austin, Texas, there's a neighborhood that looks completely ordinary. 3-bedroom houses, garages, solar panels on the roofs, kids riding bikes down the sidewalk. Except the walls of these 100 homes were never raised by a construction crew. They were printed. A machine weighing almost 5 tons rolled along a set of rails, laying down concrete layer after layer, like a baker piping frosting onto an enormous cake. No bricks, no lumber, no carpenters. And it left an uncomfortable question hanging over a multi-trillion-dollar industry. If a robot can put up the shell of a house in a matter of days, does the method that built nearly every American home over the past 2 centuries still make any sense? Before continuing, make sure to subscribe to the channel so you don't miss any videos, and tell us in the comments which city you're watching from. That method has a name: stick framing. It was born in Chicago around 1830, when 2 things got cheap at the same time: machine-made nails and sawmill lumber cut to standard sizes. Before that, raising a house meant skilled carpenters, complicated joinery, and months of work. Suddenly, 2 men with a hammer and a saw could put up an entire dwelling in days. Chicago grew on top of that idea. Then the whole country did. Today, roughly 9 out of 10 American single-family homes are built this way. It isn't nostalgia. For almost 2 centuries, it was simply the cheapest and most logical way to build. Wood is light, easy to remodel, and cheap in a country covered in forests, and every town in America has people trained to work with it. An entire ecosystem grew around it: sawmills, supply stores, building codes, banks, and insurers. To replace that, a new technology doesn't just have to work. It has to beat something that has been working extremely well for nearly 200 years. In practice, building an American house is assembling a puzzle in strict sequence. First comes the concrete foundation. On top of it, workers fasten a horizontal piece of lumber. On top of that, they raise dozens of vertical studs, usually spaced 16 inches apart. Those studs are the skeleton. Then comes the sheathing, then the roof, and only then do the other crews arrive: electrical, plumbing, insulation, drywall, paint, finish carpentry. Every stage depends on the one before it. If the electrician is late, drywall stops. If drywall stops, paint stops. None of it is complicated. Coordinating it is. Dozens of job sites compete for the same crews at the same time, and a single house passes through the hands of dozens of different tradespeople. That's why a typical American home used to take 6 to 8 months, from the first stud to the final walkthrough. The system is cheap, tested, and reliable. But it has one dependency nobody has removed in 200 years. It needs people, a lot of people. And that's exactly where things started to crack. America is running out of construction workers. This isn't a passing crisis, it's structural. Every single month, the industry operates roughly 350,000 workers short. Just to keep supply and demand in balance in 2026, the sector would need to attract about 349,000 net new workers, and the projection for 2027 is higher still. To actually meet housing demand, industry estimates point to more than 700,000 hires a year. Retirements are outpacing new entrants year after year. The workforce is aging, young people aren't entering the trades, and a huge share of crews is made up of immigrants, which became unstable as immigration enforcement tightened. Wages climbed, and it still wasn't enough. The result shows up in everybody's bill. Projects that took 6 to 8 months now stretch to 9 or 12. Estimates point to around 19,000 homes that simply never got built in a single year, with an economic hit close to $10.8 billion. And the country still carries a shortfall of about 1.5 million homes. Demand was never the problem. Hands were. Printing buildings isn't a new idea. It's been circulating in universities since the 1990s, with researchers trying to extrude concrete in layers, the same way a desktop 3-dimensional printer extrudes plastic. For a long time, it lived in prototypes and conference papers. In 2017, a company called Icon was founded in Austin, and in March 2018, it showed something nobody had pulled off before. The first permitted house made with three-dimensional printing in the United States. It was about 350 square feet, and it went up in roughly 48 hours of printing. The principle is almost provocatively simple. Instead of assembling a wall out of dozens of pieces, you draw the wall in a digital file and let a nozzle lay down a cement mixture, layer over layer, following a precisely programmed path. The walls come out rippled with a corduroy texture because the robot has to round the corners. Where the traditional method needs lumber, nails, crews, and sequence, the new one needs a file, a mix, and an operator. And it delivers a concrete wall, fire-resistant, termite-proof, mold-resistant, built for high winds. There was only one problem, and it was a big one. None of it worked outside a demonstration. The first gantry printers were gantry systems. To work, the machine had to be bigger than the house, mounted on rails, sitting on a base prepared on the lot. Setting that up and tearing it down burned time and money, sometimes more than the printing itself. It could only do a single story, and it printed walls only. Foundation, roof, electrical, plumbing, and finishes were still done the old way, by people. Then there was the question that froze everything. Who approves this? American building codes were written for wood and masonry, not extruded concrete, and the market sent its invoice. In early 2025, Icon itself laid off around 100 employees in a restructuring, while another company in the space, Mighty Buildings, put itself up for sale. Groups in several countries hit the same wall. The machine impressed everyone, but the job never penciled out on paper. For a moment, it looked like an expensive promise pointed at a very real problem. The theory worked. Turning it into repeatable production was another story. The turning point wasn't a stroke of genius, it was repetition. In the Wolf Ranch neighborhood in Georgetown, Icon and Lennar, the second largest home builder in the country, didn't print one house. They printed 100, back-to-back, designed with the Danish firm Big. And they kept growing the fleet. Nobody had ever run construction printers as a fleet before. That was the real discovery. The project started with 2 printers and ended with 11 running at once. Every house taught them something. According to executives at both companies, costs fell by half and cycle time fell by half. They got to the point of delivering a single-story, 2,000 square foot home in 7 to 10 days of printing with 2 operators. 2. In parallel came the machine itself. Instead of a gantry on rails, a robotic arm on a crane-like structure, tall enough to print more than one story and able to do foundations and roofs too, starting around $25 per square foot of wall. And in 2026, the biggest step, the company announced it would stop being just the builder and put its next-generation railless system into other builders' hands. It stopped being a spectacle and became a production line. And the suburban house may not even be the main target. The same technology is being used in a village for the formerly homeless in Austin, where 100 small residences are going up. It's being tested on military barracks and Department of Defense contracts, and it runs into stranger territory. NASA has paid the company tens of millions of dollars to develop robotic construction on the moon. Landing pads, roads, and shelters made from lunar soil itself, with no material shipped up from Earth. What started as a house wall became a question about how you build anything at all. But there's still distance. The printer does the walls. Roof, systems, and finishes are still human. Concrete carries a heavy carbon footprint, even in the newer formulations. And 100 homes per neighborhood is close to irrelevant against more than 1.3 million housing starts a year in the United States. Maybe the machine never replaces the carpenter. Maybe it just changes how many people need to be on site. Would you live in a house printed by a robot?